A straight line passes through the point P with coordinates 2, 3 and is inclined at an angle of 30 degrees with the x-axis. We need to determine the coordinates of the 2 points on it at a distance of 4 units from P on either side of P. Okay, let us begin. First, what we'll do, we'll try to understand the problem graphically. So here, let us suppose we have the straight line L, and we are supposing that it passes through the point P having the coordinates 2, 3. And then this particular line is going to make an angle of 30 degrees. We are supposing that it's making an angle 30 degrees with the positive direction of x-axis. Now we need to determine 2 points which are going to be at a distance of 4 units or lying on either side of P. So let's say this is the point, let's call it the point Q, which is 4 units away. PQ is 4 units. And we are going to consider another point R. So R is also 4 units from the point P, or you can say that RP, this distance, that's 4 units. And we have PQ, that's also equals to 4 units. Now what we'll do, we'll suppose that, let's say R has the coordinates x1, y1, and Q has got the coordinates x2, y2. So our goal will be to determine the coordinates of these 2 points of R and Q. So what we'll do, we'll begin by supposing that we have R having the coordinates x1, y1 and Q with coordinates x2, y2 be the 2 points. So our goal will be to determine these 2 coordinate values. Now here, before beginning, I would suggest you to go through the derivation of how we came out to find out the equation of a line by using the distance form. So here what we'll do, we'll be using the distance form. So first, let us consider the point P and the point R. We're considering point P and R. Then by taking the help of the distance form of a line, what we can do, we can rewrite our equation as 2 minus x1 divided by cosine of the angle, so that's 30 degrees. This is going to be equals to, we have the y coordinate 3 minus y1 divided by sine 30 degrees. And this is going to be equals to, these 2 ratios are equals to the distance between the 2 points P and R. So that's going to be 4 units. Now what we can do, we can rewrite the equation as 2 minus x1 divided by cosine of 30 degrees. That's going to be equals to 4. And 3 minus y1 divided by sine 30 degrees, so that's going to be equals to 4 as well. Okay, so what we can do, we can cross multiply and rewrite to get so we were going to get 2 minus 4 times cosine of 30 degrees, and y1, that's going to be equals to 3 minus 4 times sine 30 degrees. Now we know cosine 30 and sine 30, they each of them have got their standard values. Now we get 2 minus, so cosine of 30, that's square root of 3 over 2. Cosine of 30 degrees, that's square root of 3 divided by 2, and sine 30 degrees, that's equals to 1/2. So that means we're going to get 2 minus 2 times square root of 3, that's going to be x1, and y1, that is going to be 3 minus, so 4 times 1/2, that's 2, so 3 minus 2, that is going to be 1. So here we have successfully obtained the coordinates of the point R. So here, coordinates of the point R, will be the x coordinate, that's 2 minus 2 times square root of 3, and the y coordinate, that's 1. Okay, now let us try to find out the coordinates of the other point Q. Now clearly Q lies to the right of the point P, so we'll have to use the distance form of the line accordingly. So coordinates of, we are going to find out the coordinates of Q. For this we're going to use coordinates of point P and the coordinates of point Q. So this is going to be x2 minus 2 divided by cosine of 30 degrees, and then we have y2 minus, we have to take the y coordinate value of point P, so that's 3 divided by sine of the angle 30 degree, and that is going to be equals to 4. Okay, so which gives us yx2, that is going to be equals to 2 added to 4 times cosine of 30 degrees, and y2 is going to be equals to 3 added to 4 times sine 30 degrees. So x2 corresponds to 2 added to 2 times square root of 3, and y2, that is going to be equals to 5. So we have successfully obtained the coordinates of the point Q as well. Thus coordinates of the point Q are going to be 2 added to 2 times square root of 3, and the y coordinate value, that's 5. So we have successfully obtained the two coordinates of R and Q, which are going to lie 4 units on the either side of the point P, such that it makes an angle 30 degree with the x-axis.